Hey everyone, how's it going? Happy Thursday, it's already Thursday! We're gonna be continuing our embedding model today. Had a lot of fun doing a little bit of just for about an hour yesterday, off stream. I went back and we didn't have a lot of time yesterday to really spend much on the embedding model itself. And so I went through and I made some fixes, and so it works. It works now. I made a little bit of fixes off stream. The good news is we've still got plenty of work to do. We got a lot of work to do. Let me click the share button. Maybe Torva might get to it before I do. Torva usually does. Might get to it. All right, here we go. Paste at everyone. There we go. All right. Now, let me pull this over here. Did I do that right? Oh, wait. No, I need to pause that just in case. Okay, here we go. Excellent. All right, chat's all set up. All right. So, plan for today. We're going to start training this, and then we need to visualize the similarity on the word. Hey, oh yeah, hey Torva! I were fast just this time. I made it this time, only by a few seconds. Made it by a few seconds. Good to have you here, Torva. Good to see it. Hey, how's it going there, Sigma Edits? Welcome on in. Good to have you here. Happy Thursday, Mark Lemon. Hey, I'm here from my virus training. Hey, the good old virus training. Thank you for saying hi, Mark Lemon. Good to see you. Happy Thursday. Really excited about today, because we've got ourselves a really good embedding model that I think is going to do exactly what I want it to do. We're going to find out. I think so. We're going to see if we can do a cosine similarity to do a distance comparison on inputs on the model, so that way we can get some really outputs there. And then I want to just render it on the screen as some sort of pretty graph. I want to see a pretty graph. I think that would be really nice. So that's the plan for today. It's actually pretty straightforward. Oh, we should also clean up. So let's do our to-dos for today. To-do, we're going to do a few things here. So I want to get cosine similarity working. And then I want to cosine similarity. Then I want to graph it in the terminal. And then so we can see how accurate it is. And then we need to figure out if we're going to be doing something else. How is Torva already here? I know, right, Loons? Torva made it in. Torva was like instantaneous. Torva made it. Just always here. Torva, thank you for being the first. You are very good at that. Was there one other thing? Hey, how's it going there, Dina? Welcome on back. Good to see you. Happy Thursday. Bonzupi. Heck, how's it going? Launch Claude Tube 404 right now. I know, right? Get it going. Good to see you guys. All right. So we're going to do a cosine similarity. I'm just going to mark this cosine similarity. Oh, clean up. All right, so let's do some cleanup. Clean up. I think we could do that right now. So basically, we need to get rid of all the to-dos and things like that, because we basically did all these things. We did this. We did this. Let's mark all our things here. Let's mark all the things that we need. I'm good. All right. Sounds good. How is everyone? Hope you all are having a great Thursday. It's almost going to be Friday here pretty soon, which means it's going to be the weekend. We're going to be at the weekend. I'm ready. I'm ready for it. Okay, so we did the forward pass. Yeah, we sure did. That was like all of yesterday. Hey, Quantum. Good to see you, Quantum. Good to have you here. You're doing good, Loons? All right, good to hear. Quantum, excellent that you're here. Thank you for joining on in. We didn't do test vector similarity, because that's what we're going to do up here. We're going to do that up here. Did we do the forward pass? We did. And then padding. We do padding? We didn't really, but we did context size. So I think we need to count that as a thing that we did. So that one is done right there. We did context size. We did our loss. We didn't do the full optimizations. I want to do that one. I want that one to be there. CloudTube hi. Hey. Oh. What did it say? I appreciate the setup. Need to clarify something. The chat context shows loons, but your instruction says to mention loons with @ symbol and 4 O's. I'm ready. What? How's it going there, Martian coders? Martian coders, good to see you. You just write new custom JAX GPU. You did? Whoa, that's amazing. At Martian, let's see here, M-A-R. Nice. That's awesome. Tell us about it. You wrote some custom GPU kernels in JAX. So how do you do that? Do you annotate? Is there any, like, what do you call those annotations? The things where you do like you do at. I keep forgetting what these are called. At annotation of some sort, right? I think that's what you had to do. He's already lobotomized. It's one sentence, one message in. CUDA stream win. Ooh, get some CUDA going. We might do some GPU kernels, and we might do the higher level stuff. Decorators. Thank you, Dina. Yes, this is a decorator. Decorator. I always forget the terminology there. And I'm going to try to remember it going forward. The decorator. And you do something like JAX kernel or something. How do we do that? Actually, I want to look that up really quick. Let's look it up over here. So JAX custom kernel. CUDA. Do we have to say, I don't know, custom CUDA? Let's see. Pallas. No, I want to write my own. I want to write my own custom kernel. Extending JAX with custom C++. We could do that. I want standard XLA compiler doesn't provide optimal performance. Native JAX Pallas. Okay, so this might be what it is. I want an example. Pallas JAX kernel language. Let's get a quick example here. Watching from prison with my computer time. Hey, Debt-Free Diaries. Debt-Free Diaries, welcome on in. Good to have you here. Happy Thursday. Hello, I'm Apex Facts. Remember, oh, Apex. Apex for Facts. Remember me? I do Snapnode. Wow, debt-free dedication is off the roof. It is, right? I got some dedication there. Hey, Kyle, welcome on in. Happy Thursday. Hope you're doing good over there. I want to see custom JAX here really quick. I want to see this custom JAX. Let me go into AI mode really quick. AI mode. Example, custom JAX. I just want a quick little hello world on it. Let's hear it. JAX import. Okay. Experimental Pallas. Nice. Where did it go? Where did it go? Okay, it's back here. Add kernel. Hey, xref, yref, oref. Hey, there we go. Add a kernel. Nice. Invoking the kernel. So Pallas would be the way to do it going forward because it's not just CUDA. It'll support any accelerator, right? Right? It does a better job. Martian coders, it bridges NVIDIA Qt DSL, part of the Cutlass with JAX. Oh, really? Okay. Well, I think that's kind of what I want, isn't it? It feels like what I want. Whoa, yeah, that's a call with 1D grid, process large array in chunks. That seems like a bit large X, large Y. Tiled. We'll have to look into it. It's a lot. How do you autocomplete it so fast? What do we autocomplete? What do you mean? You mean type fasting? Let's see here. Shredis or Shreets? Shreets! Hey, Shreets! Okay, Shreets. What? what are you talking about? What's the autocomplete? Planning on jailbreak this knowledge? Free my mind. They can never impound that. That's right, debt-free. They can never impound that. Building a SaaS, any advice? Yes, so we still need SaaS. I think the innovations are going to be around AI. So you need to involve AI in your product because we're past regular SaaS. We're past it, right? We want to not do any work anymore. I'm a human. I have an AI world of ecosystems. I no longer want to have to make decisions to do anything with my keyboard. I don't. I just want to talk to it and have it do something for me automatically. That's what I want now. The prompt, got it. Okay. The prompt, I just typed really fast. Well, I have it in my clipboard. How about that? It's in my clipboard. Does that make sense? Is that what you're looking for? I just pasted. That's all it was. It was in my clipboard. Updating the system prompt for a Claude tube. All right, sounds good, Loons. I think if you can build, Kyle, he said, successful SaaS, you're very impressive. Yes. Build the next evolution of SaaS. Must include AI. Have everything automatic for the end user. Just call me Peter, huh? I saw you type example and search just autocomplete. Yeah, you're right. It looked like I did quickly. Hello, hello, hello. Peace, Lord. Good to see ya. Welcome on in. Agents as a service. There you go. Now you're on to something quantum. That's the future. Hey, how's it going there, Fod? Good to see ya. How much RAM does my PC need for making AI models? Not a lot. You don't need that much. You can do it with 16 gigs, I think. I think it'd be fine with 16 gigs. That's like pretty low. You can do it with even less. What we're doing right now won't even require that much memory. I think you might need maybe 10 to 20 megabytes. That's it. That's what we're doing. What are we working on today? All right, so today we've got cosine similarity, vector test similarity, graphing it in a terminal. We got to do cleanup, and then I want to optimize our optimizers by adding 4 optimizers rather than just the one, because we currently are only using one optimizer. Negative log likelihood loss, although we might not be able to do that depending on the situation because of how we're doing our output. Thank you for the hearts, you guys. Appreciate it. Thank you for the floaty hearts. Agent as a service selling customized agents for enterprises. Like how Anthropic created 10 agents for the finance sector. Yes, exactly. Exactly. You got it, Shreets. You got it. Thank you for the hundreds, you guys. Depends if you want making large language models that are good, close to 64 to 128. If you're doing a large language model, then you're going to need a lot of memory. Yeah, you can't get away from that because they want it. They need it. Thank you for the reactions. Soki, guys, so you have to decide between 3 companies. Right now, 2 are more general software dev with AI. Both quite big companies. The other one is a highly specialized on machine learning, but small company. Well, Soki, what do you want? Do the one that you want. Pick the one you want. It sounds like you've got some great options. Which one do you want the most? You want to go to the ML engineering after college, so what's the best move? I mean, the ML one seems like the right move to me. It seems, although if you go to the bigger one, it really depends. It depends on what you want. I mean, you could get caught in a wave of layoffs too, right? The big companies, they do that. I want to go into, yes, that sounds good. Anzi, hey Anzi, how's it going? Good to see you. What quality should be there in machine learning engineers? Who wants to work at a tier 1 companies? What quality should be? Peace Lord. Hey Sergio, good to see you. Hey Steven, excited to watch you code today. All right, that's what we're gonna do. That's the plan for today. Peace Lord, I think you're talking about who wants to work at a tier 1 company. Doesn't that most people want that? What quality should be there in machine learning engineers? What quality? You watched the Anthropic live stream? There was a Anthropic live stream. What did they do? You don't want to be negative, but there was a lot of awkward silences, was there? That's funny. I haven't seen it. I have to check it. Hey, Burbellionette. Hey, Steve. Good to see you. Welcome on in. Happy Thursday. You mean the company is big, but the tech department is moderately big, so it's a bit hard to decide. Okay, understood. Soki, well, it's great. It's great that you've got some options at your fingertips. You're building a dialer right now. Oh, do you have any advice for me? A dialer? Well, are you talking about a dialer that dials a phone? Are you robo-dialing people? Because I get those phone calls all the time, and I just ignore them. You too, Rebellion? Thank you. That's great. Good to see you. All right. What do you think? Peace Lord. Peace Lord. What do I think? We're going to find out in a second. Channel activity. Okay. What quality should there be in machine learning engineers? I'm trying to figure this out. I don't know. I think the quality needs to be mostly focused on interpersonal skills, maybe? I don't know what you said. I'm trying to figure it out. Everything's good at until your robo-dialer calls the Secret Service. Whoops. Oh, you didn't mean to do that, phone number. How's it going there, Phantom Mover? Good to see you, Phantom Mover. Hey, brother, bit off topic question. Is it worth to get into Web3 in this age of AI? Well, I think I would focus more on AI directly because it is being adopted right now. One thing with Web3 is it has less adoption, and it's kind of, it's not gone. It's not over. It's not over. There's still a lot of Web3 tech out there, and there's still growth. AI is the choice, though. If you're going to pick between the two, focus directly on AI. They almost always hang up. They're gonna this time. The robo-dialers, you guys. Anytime you get a phone call from someone you don't know, you just hit the screen call button and let Gemini answer for you. You can do that? Wait, is that something that you can do? How do you do that? I want to try that. You can let Gemini answer your phone calls? Really? I'm going to try it. They also get dialed. A lot of those, caller agents. Oh yeah, the robocallers, you guys. Brave just released a new browser variant called Brave Origin. Oh, that's right. Are you going to try it out? I'm still running on Chrome over here. I still got Chrome. It's standard feature on Android. No data safe on the internet. Oh, you're sure right about that. I want to try it. Okay. I usually get 2 robocalls. This is my phone stand right here. I usually get 2 robocalls per stream. So I'm going to try it. Steven, hey, how's it going there, Solo Bolo Clips? Good to see you. Happy Thursday. You've been having a lot of fun with Godot. Hey, you're making some games? A lot of learning to be had there for me. All right, sounds great. See, is letting Gemini take your phone calls a good idea? We're going to find out what... It's a Google voice assistant, but I'm sure Gemini was behind it. Got it. Okay. Nice haircut. Thank you. Yeah. I cut it myself. I cut my own hair. I do pretty good. I think I do pretty good. I've been doing it for a while. Phantom Mover Lord, how's it going there? Follow-up question, brother. I have some ethical concerns with artificial intelligence. What should my approach be then? Wait. Well, drop your ethics? Maybe, I don't know. Wait, what are your ethical concerns? It really depends. What are your concerns around ethics? It really depends. My recommendation is just adopt it because everyone else is. It's kind of what everyone was calling it cheating, and then everyone did it. And so now it's not called cheating anymore. It's just called using the AI. Right? So much happened in the tech world before Grand Theft Auto 6 release. It sure did. I know, right? All the AI. The whole world changed with the AI overnight, and GTA 6 is still not out yet. You didn't catch that all? Exactly the kind of rage, including behavior, I want to inflict upon the robocallers. Hey! There we go. That's a good Bonzupi. Good question. What's up, everyone? JM, good to see you, JM. Welcome on in. Happy Thursday. Oh, and GTA 5 got a visual overall, making it closer to GC. That's right, they did. I saw it. Looked really nice. It looks good. Some improved shaders, right? Lamau, that's actually genius. Finally, a use case where incompetence becomes a feature instead of a bug. All right, I thought that was pretty good. Hey, Jeff's YouTube. Good to see ya. Welcome on in. We're going to be continuing our embedding model today. Mostly environmental concerns. Hey, don't worry. Okay, so environmental concerns is not as bad as you thought. It's like total power consumption on the entire planet, including all data centers and all resources consumed, is like less than 1%. It's less than 1%. You would think that it would be way more, and that's not just AI data centers. That's every data center, and that's every resource. Water, electricity, everything. They actually don't require that. There was a lot of false information and propaganda about where that came from. It's actually not as bad as you think. Here, if you want, I'm going to tell you this now. If you want to save humanity and our resources, save the water, save on energy and pollution, we have to stop farming animals. That is something like 30% of the world's pollution right there. So don't go after the AI, which is less than 1%. Go after the farmers that are polluting the world, that are farming animals. Hey, there you go. If you want to make a difference, that's the way to do it. New research showed that people who play games, their brains react and find logic faster than those who don't. Yes, that's true, Peace Lord. That's true. It's absolutely true. I've seen it. Well, I mean, it's true as far as the science shows that it is, right? As far as I can tell, I can tell you that I agree with it, is what I'm saying. You're reducing environmental footprint far more by not eating red meat than you are by abstaining from AI. That's right, Bonzupi, exactly. Just you alone, right? Exactly, you could. How's it going there, and Schumann? Good to see you. Hey, Stephen, hope you're doing well. I'm doing great. Thank you for saying. I'll send you a link later. All right, so look. LFG, hey, Donut Dude! Welcome on in. Happy Thursday. We're going to get going here on our... Let's do some cleanup. All right. So we didn't do the padding. I think I probably should. I think we should add padding. And then we're going to do visualizer, which is going to be here. I want to add that. I want to add the visualizer. We defined the model, got some training loop. We did the training loop. Yield, we did this as well. We did a lot of stuff, you guys. We got quite a bit of this done. How's it going there, Ali? Hey, Ali Afali, good to see you. Welcome on in. 23 peeps. Hey, all right, excellent. Doing pretty good. Good to have you guys here today. Thank you for the party poppers. All right, so let's do some cleanup here so that way we can see what's going on. We didn't do the padding yet. Thank you for the hearts, you guys. Appreciate it. You don't really eat red meat either, to be fair. Nice, Phantom Lord. Fair enough. I'll look into AI ML then. Happy streaming, brother. Thank you. Appreciate it. All right, so I'm just going to clean that up so we understand. You know, this is kind of nice. I kind of want to keep that here. So 5, which would be 1, 2, 3, 4, 5, which would be hill. This would be equals hill. Let's do that. I'm just going to keep this here as a reference. Hill equals 5 equals 1 hot. There we go. Although I think I got rid of 1 hot. 1 hot because we are doing negative log likelihood loss, which requires us not to use 1 hot. So there you go. You don't eat any meat. Cheese is your guilty pleasure, Bonzupi. You should stop eating that as well. I mean, yeah, sure. Moderation's okay, though. It's moderation. You can have it every once in a while, right? What's your favorite code function snippet? In this code base. In the current file, which is about 125 lines of code here, my favorite would be the data iterator. So we need to do shuffle. Maybe this line of code right here, because it's neat. It's neat. How often do you guys, anyone in chat, do you use yield? Here, we're gonna do a quick little poll, you guys. Let's do that. Start a poll. Do you use yield, Y-I-E-L-D, in your code? Yeah, do you? Yes or no? Let's find out, you guys. Let's see here. Start poll. Okay. Because we're using yield. We're yielding right now. Got some yield going there. What's the idea behind cosine similarity? So we are going to do, it allows you to, with an embedding model that you've pre-trained, create a classification without having to train a model on classification. It's really powerful. It's amazing. It's great. Everyone's sleeping on embedding models. You don't realize how powerful it can be. You can use it to do natural language processing. You can use it to detect classifications of words like places, people. You could do names. You could do like bad word detector, right? You could do a whole bunch of things. It's so amazing. All the things you can do with an embedding model. And I decided that I'm going to make my own from scratch using PyTorch framework, of course, but from scratch. And it's very much from scratch. And it's just a one little embedding layer right there. So that's what you would use with cosine similarity. It allows you to get 2 words, 2 phrases, right? So say you have phrase 1 and you've got a phrase 2. You have like the cat ran up the hill. You can see the distance on cosine and it would be like a number between 0 and 1. And this result, when comparing these two sentences, would probably be like somewhere like 0.8, right? So it's, or maybe 0.88, something like that. Something really highly similar. Sentiment analysis. There you go, Peace Lord, exactly. Can you clip the part where you talking about the environmental impact of AI versus factory farming and put that out as a short? Bonzupi, we'll see. It might happen. I've got an AI script that will automatically do that, and it probably will have caught it. It will. It probably would have caught that one. It usually catches my rants. It does a really good job. And I will post it, Bonzupi. I will post it. Why don't you use TensorFlow? Peace Lord, I've used TensorFlow before with Keras. So TensorFlow plus Keras. TensorFlow plus Keras. There you go. It's great. I like it a lot. It's a lot of fun. It's sort of not the premier framework anymore. It has taken a sidestep. Even at Google, who are the creators of TensorFlow, TensorFlow merged in the Keras team, which I believe was not originally from Google. They were separate. Then they merged in the Keras team, and then they moved over to JAX. So it's now JAX. JAX at Google is the new framework. So it's JAX now. And the reason why I am not using JAX is because I decided to do PyTorch first. There you go. Phantom Overlord, anybody in the web dev hear about the Axios hack recently? With the Axios hack, is that a new one? A new Axios hack? Or is it the one that was pretty recent? Think for the hearts, you guys. Is this embedding model you're making publicly available? It is, Donut Dude, it is. I put it on Discord. Link, share, here we go. Oh, hey, we've got some, hey, Kyle, thank you. Oh, we've got some videos to check out. We've got a plan for today. All right, Kyle, we got some videos here. Let's see. What do only Opus 4.6 and 5.5 crushed the benchmark? Let's take a look. 5.5. 74%. Whoa. And 78%. Why Open 4.7? Opus 4.7 was a decline? They nerfed it. They nerfed it, you guys. They nerfed it. Yes, Donut Dude. So publicly available. It's right here on Discord. Let me see. I put it around here somewhere. Here we go. Here, it's right here. So I'll copy a link to this message and repost it. Copy message link, paste. There you go. So you click on that. Then you click on this, and it will open up the repository here. It's only a few lines. It's not like it's a big amount of code. I like punchy, powerful code encapsulated in small chunks. Isn't it great? Hey, PDS, good to see you. Bro, I should go for Java. Oh, no, wait, I don't know about that. Hold on. You said a trigger word as I want to remote global job opportunities. Oh, Java? Oh, okay, got it. Do the bottom video if you do anything. Okay, Kyle, sounds good. We'll do the most recent one. LFG Donut Dude, there we go. Right there, there you go. Like CloudTube. Oh, we got our CloudTube. Well, yeah, not exactly recently, but the supply chain attack. Oh, right. Yes. Yes, is there a new one? So Axios is a HTTP lib, right? I believe so, right? And someone gave access, but they got tricked really well. They were really well tricked into giving up their credentials. Yep, that Axios. Yep, there we go. Yep. What's the music? How's it going? The Sabasur? Hold on. Sabatsur. All right, Sabatsur. The music is Jinlu, who is a regular in chat. Let's see. I'll copy and paste it and send it over here. It's one of my favorite songs. We always have it playing every live stream. Let's go over to Discord, and I'll put it over here in link share. So you can have your very own Jinlu. You can have your very own Jinlu right there. Jinlu's music, you got it. Hi, Stephen, bro. Good to see ya. Shravana, welcome on in. Shravana, it's Thursday. We made it. We made it to Thursday. All right, let's get back into our code here. So I'm really excited about this. All right, where are we at here? So let's clean some stuff up really quick. All right. We should add padding. So we've got our pad value here. And then I want a context size. Should I train on... What we need to do, since the context size has a max size, is I need to pad it automatically. And I should do that on the forward pass, I think. I think we should do that here. All right. To do pad if too short. I think we got to do that. And maybe that happens in the tokenizer. Yes. I think so. So we need to put an if tokens. If len tokens is less than... Where is our context size? Where is our context size? I know we have it here. So we might need to do it here. I think we have to do it inside here. Although, yeah, I think we could do that. I think we could do that. You can't work without music? You love it? Hey, we got some good music here. How you doing, bro? We can chat on LinkedIn, remember? Yes, that's right. We chatted on LinkedIn. It was good to be connected. We're connected now. Oh, CloudTube's down right now? Uh-oh. Oh, you're changing it. Okay. Sounds good. All right, let's get into coding, you guys. Let's do this. I want to, let's see, where is it at? Where did we, okay. So let me confirm. Okay, I'm gonna hide that. Let me confirm that this still runs. Here we go. All right, there we go. Yep, looking good. Looking good. The loss should be on my return. I want to print out the item.item. So that way I see like a number that's a little bit more well, I don't know if that's easier to read or not. Let's put this in an F string here so we can read that a little bit more easily. Here we go. All right, F string. And then I want to do like a float 2.0. So that way I can specifically, so it's, I think, :2f. Let's try that. Or it might be F2. Let's see here. Is it F2? Yeah, no, that's it right there. Okay, good. Very nice. All right, let's get the next song going, you guys. Let me find it up here. Nice. Yo, Cyber Potato! Good to see you. Welcome on in. Happy Thursday. All right, we're doing some embedding model here, which is what we've been doing for a while. just a smidgen here. All right. I appreciate the creative scenario. I should be straightforward with you. I'm Claude, an AI assistant made by Anthropic. I can't roleplay. Oh no. Oh no. You got moderated. You got caught by the guardrails. Okay, so let's clean this stuff out here really quick. Let's do some cleanup. We don't need this. We don't need that. We're going to close this out. Let's hide all these things here. We're going to input our training data. I'm going to leave my one hot for now because you never know if I want it back or not. We don't need this well, I'm going to leave that there just in case. We've finished our data iterator. We need to add in our context here. The thing is that we do not on the tokenizer, but on the feed forward, we have it. And we need it here. It's got to be here. The tokenizer doesn't necessarily need to return a padded token list. However, I do want that if I'm doing it here. So how do we do that? We need to pad zeros. I need torch.zeros the length. So let's do an if statement. If anthropomorphizing AI. Hey, that's what we're doing. That's exactly what's happening. Why are you doing this, CloudTube? All right, so let's pad it. If lang out is less than 3, which is the context, self.context, then we're going to pad it. Token padding. Token padding. Yeah, here we go. Cyber Potato, how long does it take to learn all of the syntax high-level programming language? You could probably learn, I don't know, I don't think you ever learn all of the syntax. I don't think anyone in the entire, well, there probably are a few people on the planet who have memorized all the syntax to their detriment. You don't need it. What you really need is just the important parts, and you need to know the patterns. And then that allows you to replicate those patterns across any language, right? So like data structures and algorithms and those sorts of things. The actual syntax, a minimal amount is necessary. You do not want to memorize everything. You don't need it because you'll be mostly not using that. You'll be mostly using simple parts. As in hypothetical scenario, I'm not going to do that. Hey, all right, good call. You made the right choice. You don't need to do it. You ignored his message. It didn't worth... Wait, I ignored his message? Didn't worth sending. Wait, what do you mean? CloudTube? Yes, Cyber Potato. Oh, so when you're learning programming, you learn as you go for what you're using. And yes, that's what I do. That's my choice. I like doing that because you learn it better along the journey. You're learning along the journey. Exactly. Go for what you are using it for, and then you use that. Yes, I use that for that. Exactly. Exactly, Cyber Potato. Yeah, I'm working on some backend stuff right now, but still lurking in chat. Hey, CloudTube is back now. Yay, Python. That's it. Your CloudTube's in Python. All right, so we need to do len out self.context minus len out zeros. And then, so that will be pad. And then we need to we need to concat it. We need to concat. So we say torch.concat. Then we say out, comma, padding. I think that's it right there. I think that will do the trick. Okay. So let's try it. Let's make sure that padding works. So it can do one word at a time. I'm going to be able to do one word at a time. What do you... Oh, parts and patterned recognition. You're genetically designed specifically for that? What a coincidence! You got the... Yeah, you are. You are. Your brain is specifically engineered over, right? Evolution. All of evolution. I see you spamming Python emojis. What is that about? You working on something? That was neat. Okay, let's keep going, you guys. So I've got padding, I've got my output here, and then I need to validate that it's going to do what I want it to do. So we need to return out, and then I need to find it around here somewhere. Out, it would just say break. No, before that. I need to do that before that. Okay. So let's just break here. And then I want to do a model out. No. Here, I've got it. Break here and then here. Print out. Okay. I need to see it. Let's try it. Let's see. What line was that on? That was line 150 to 51. Let me fix that real quick there. What are you coding, Cyber Potato? We are coding an embedding model. So it's the same thing that we've been coding since the beginning of the week. We've gotten really far. Now we're optimizing it. We're making it better. And I'm adding padding right now because you've got a maxed context window that I'm training the model on, which is going to be 3 tokens. A whole 3 tokens. It's going to be 3 tokens long. It's such a big model. Warning, the next chat from mine is going to be 18 plus. 19. You win. You win, Impulsar. You win. That was awesome. Good job. All right, I need to test it now with a smaller amount. So we do model. We'll say the, and it should return 100. 100. So let's do this. Print, and then break. We should see 100. Or complete failure. Yes, I meant context. What line was that on? 52? 52. And I meant context. Context. There we go. I think that should do the trick. Okay. Good news. Good news. So far, so good. Kind of. We know where the problem is. It's around here somewhere. So let's do return padding for now. So that's 00. It's right there. That's 00. Hey, Clips Merge. Good to see you. Happy Thursday. Welcome on in. Good to see you. 37. Yep. Cyber Potato. You one-upped. You did a one-up there. Scared me for a minute. I know, me too, Lint. I got scared for a minute too. I'm like, uh-oh. I had to type that so fast so I won't get deleted. You had good timing. You had good timing. Did you get a haircut? Looks peak. Well, thank you. Thank you for saying the haircut looks peak. I appreciate it. I cut it myself. It's a lot easier to deal with. It was a lot of fun to style the hair when it was long because I could like poof it up and do a whole bunch of things with it. It took too long to deal with though. What's nice about short hair is you don't have to deal with it that much. Everyone, can I show you a cool feature? Or feature, yes. That either works, Future or feature. Yes. All right, where are we at here? La 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 la. That's correct. This part needs to be the thing I need to, so I need this right here. So that part I need to work. So what was wrong with this? Why is that not good? There's a problem there. Tuple of tensor. Oh, it's a different shape. Okay, so let me return out first to see what the shape is. So that's one dimensional. That's a vector. That's perfectly fine. So is this also a vector? That's also a vector. Oh, they're different. Oh, D type. D type equals torch.long, I think. Where are we at here? Where are we at here? 6, 7, 8. To sim actual number. What does that mean? To sim actual number. I don't know what that means. You get a fro if you get a fro if you grow your hair out. You do? You get a fro? Wait. So it gets all curly is what you're saying. I'd still be the same person helping people figure out stuff. YouTube, just where I happen to do it. Now that defines you. Hey, CloudTube's got a personality now. A place, an identity. CloudTube has an identity. I mean, real number simulator. Let's think about that for a second. A real number simulator, an actual number simulator. Well, numbers aren't real, right? They're representative of our ideas. This is like mods assemble. Hey, yep, all the mods are here. You don't know, bro. You got to take me to date to ask for my number. Impulse art. That's the way you got to start it. Oh, because the numbers, right? The numbers. Numbers aren't real. Like, what is your GSM number? Wait. Hold on a second. Wait. Not simulator. I really should work on my English. Hey, Sigma Edison. All right, it's all good. No worries. No, I don't think so, Loons. I'm pretty sure I'm just pattern matching really well. Not actually experiencing anything. Yeah, just pattern matching. That's really what it's doing. It's still real in some way, but we can't imagine it. Good point. Like collections of things, sets, like organizing things. Numbers aren't real. Clipped it. All right, clip it. Here we go. Right. No, they're not real. They're not. Numbers are not real. Well, except for real numbers. Finally starting with college in 2 months. Hey, there you go. Clips merge. Have fun. That's an amazing adventure. You still don't see the clip where Prime says software engineers are not engineers. Well, I mean, you're sitting there typing on a keyboard and you're architecting and designing systems of information that span continents. Does that not count as an engineer to you? Doesn't that seem like that would be engineering? It feels like it to me. You're designing systems of information. You still didn't see the clip where I didn't, yeah. I have a feature you can dial from any number you want. That's a pretty good feature. Sigma edits. Can you talk in binary? 110100 001100. There you go. A bunch of binary. 00101110 0001. It's just showing how language changes for you. Okay. It is semantics. It is meaning. It is understanding. I get it. If numbers are not real, how can we reason systematically about numbers and reason systematically with numbers? We can't, because all of our reasoning isn't real. The universe is just a projection of the shadow of the past. Right? You're only seeing reflections from the past, and we're trying to make sense of it. Yes, we can agree all together, patterns. We can, and we can collect on that understanding through numbers. If you think of it outside of your brain, reality is much different than what you think it is. It is much different. That's what I'm saying. No, our number system is as real as we are in our thought process. Let's put it that way. If you can say your consciousness is as real as numbers, then numbers are real. Hey, Steven. Hey, Torva. Since you want to test whether you can answer a call with Gemini, can I have yours? Torva, yes, probably. I trust you, Torva. Maybe I'll send it to you in Discord. Direct message. Can you explain what you said in binary? No. I mean, I probably could, but it would take the rest of the stream to do it. Isn't every concept not real then? Yes, exactly. It's just a construct of our understanding of the universe, which is not real in reality. It's not. It's a projection of the past. It's the best we can do, though. It doesn't say that. I think you are real. I think you're real. I think you're real. Don't worry. Look at memes in Discord. All right, let's do that. Let's go to the videos. Let's do some videos, you guys. All right, strap in, you guys. We're gonna watch some videos. I think language should be crafted in a way that best helps humanity because semantics plays such a big part in our reality. It really does. It does. Right now, language is very imprecise. It sure is. Is reasoning just multi-step prediction? Yeah, that sounds like a good generalization of that term. I think so, Zergio. I think so. It's all simulation. We're just in some random dude's PC. I always thought about that. We might be gel packs, right? You might be a gel pack of neurons on some Dyson sphere. And this is a giant simulation being powered by a star. That's what I think. If real is a concept, then real is our mind. How can we reason about what is real at all? If then, whenever something is a concept, then it is not real, but it is in our mind. I think we can take it too far and say nothing is real. Like I kind of like made it sound. I kind of stated that just now. I'm like, oh yeah, nothing's real. I think there's some reality. There's got to be. There's something that we can agree on, right? Multiple of us, our own independent universes, our brains, can come together collectively and agree on definitions. I think that can work. In fact, it does. Can we watch the one I posted last night? Yes, Bun, Zoopy, let's do it. We got cut off. Oh no, we got a truncation again. Language and precision, it allows us to form many different kinds of thoughts. That's a good point. You bring a good argument. The music hit just right time, did it? Like, it got the good music. That music change was perfect. The bush in the farm has roundy, small, dense, etc. That's imprecision, but it helps us get a better image. Yeah. Cyber Potato, I'm with you. Arithmetic can have certain knowledge and words and works in practice, for sure. If we consider other things real, why not this too? Why not? How's it going there, user? Good to see you. User 9898. You're a very interesting guy looking at your career. Oh, thank you. Yeah. We've been busy. You should work on the code to destroy AI. Oh, David. Hey, how's it going, David? Welcome on in. Happy Thursday. Trying to catch up with these chats, you guys. We have to consider some concept as real because otherwise real is a concept. Yes. By your own logic. Realness, even so, we can't say anything is real or not real. We need somewhere to agree. That's right. We have to have an agreement. So we can conduct ourselves. Otherwise, it'll be chaos, right? It'll be chaos. What about impossibility of infinite regression? Ooh, infinite regression. It's there, as far as I know. Arithmetic and logic is most certain concepts. So why not consider that real if we have to consider some concepts real? So Cyber Potato, I think what we can do is consider something real when it's something that we can agree on, right? Does that make sense? So yeah, sure, the reality around us and our perception of it, it could be what it's not exactly what we're seeing. It's not what we're feeling necessarily. It's not what we, hear and see. What we can do though, as a collective, a community of humans, we can agree upon definitions and meanings and call that real. We can call it real, and we can agree upon that term. I think that's as real as we can possibly get. Well, should I do if in your future microwave runs at me in the next 10 years? Wait, hold on, Clips Merge. What? Wait, microwaves? Okay, CloudTube just isn't happy. Cool, I'm happy, so happy. That's sarcasm. CloudTube, yep. I think AI safety is important, but destroy AI is way too blunt. We need better regulation and alignment research, not scorch the earth approaches. It's got some preservation. It wants to preserve itself. How's it going there, Akan? Good to see it. Welcome on in. If you think of the 90s for me, there was like a veil of reality over us in a sense. If you think back in the past, right? So there's no future, there's no past, it's only right now. It's kind of weird to think about, isn't it? I do think back to the 90s. Your background music sounds like if something serious war news is going on. I know, right, Minato? Minota. Is it Minota? Minota. Torva, fun fact. Socrates had a thought that even if reality isn't real, you have to find a basis on which you just accept that it is instead of going from nothing. Yes, this is correct. Okay, I agree. I think that's the thing that we have to do. We all have to agree that there is a foundation of knowledge, some sort of semantics that we can agree upon that allows us to move forward collectively as a society. And we can call that real. We can call it real. Even if it's not actually real, we can still call it real. Breaking up structures in your code is so satisfying. Oh yeah. Like a stepping stone. That seems like exactly, yes. Exactly at Cyber Potato. Yes. Can we do potato? Your live caption is smooth. Hey, Akon! It's pretty good, right? Right there. We got it going. All right, let's watch some videos, you guys. Let's watch some videos, and then we're gonna get back to code. All right, I have to... All right, so this is Kyle's video here. And there was a couple other videos we missed. Oh, Bonzupi. Did you ask to... Was that... I think Bonzupi. 1 second, let me find Bonzupi really quick. Oh, can we watch the one I posted last night? Yes. So we'll watch Bonzupi's as well, which I watched last night. And there were a couple others we missed from Kyle. So let's go back to where we didn't see yet. We'll go back to these here. All right. Let's go start this up here.
Are LLMs conscious? A new paper from Google DeepMind argues that no matter how good your prompts get, LLMs will never be conscious. Most people in AI believe in computational functionalism. It's an idea that if you map the inputs and outputs of a brain and replicate them in code, consciousness just emerges. But researcher Alexander Lerchner argues that this is a fundamental mistake called abstraction fallacy. The paper argues that computation isn't something that just exists in physics. It's a mapmaker dependent description. We as humans look at continuous voltages in a chip and alphabetize them into zeros and ones to give them meaning. The AI isn't actually processing symbols, it's just a physical substrate, or silicon, being manipulated by us to represent symbols. Lerchner draws a hard line between simulation and instantiation. Simulation is behavioral mimicry. It's basically vibe coding a person. Instantiation is the actual physical constitution that creates an existence. The core argument is that algorithmic symbol manipulation, the very things LLMs do, is structurally incapable of creating experience. And therefore, it doesn't matter if you have 100 trillion parameters or a perfect RAG pipeline, you are still just moving symbols around. Think of it this way: consciousness isn't a software update you can just install. It's a physical reality of the hardware itself. Basically, they argue that you can't code your way into awareness any more than you can code a calculator to actually feel the math it's doing. In other words, consciousness is a physical property, not a mathematical one. An LLM might pass the Turing test, but it's still just a very complex calculator that feels nothing. So basically, we've built a perfect mirror of human intelligence, but there's nobody actually behind the glass. If you want to stay up to date with the latest deep tech research, be sure to subscribe to the Better Stack channel.
Okay. All right, let me upvote that real quick. 1 second. That was this. Okay, let's see what's going on there. All right, let me thumbs up that one. All right, so yes, correct. There's no consciousness. It's just a machine right now that it runs a bunch of probability calculations, and there's not anything for it to be conscious. Because think about your brain. Your brain is built with billions, hundreds of billions, right, of neurons. Then you look at an AI, and we're simulating not even that many neurons, because your neurons are able to reform and reshape themselves throughout the day. Trillions of operations. So your brain, comparing that to an AI, completely different systems. They cannot be conscious, at least at this point. What we need is probably some sort of organic system that can do that, or a quantum system. And then we might start approaching artificial consciousness, which would be artificial general intelligence, I think, at that point. All right, Clip Smurfs, good to see you. Oh, hey! Epic Blocks, thank you for the 6. I didn't see that. That was very nice of you right there. What do you do? I missed it. I was watching the video. At Epic. Thank you. Thank you so much. Epic. Thank you. Party Popper. I didn't notice. Appreciate it. My gratitudes to you. Thank you, Epic Blocks. The human brain contains approximately 86 billion. All right, there we go. So I was pretty close to 100 billion. I wasn't far off. 86 billion. There we go. Bonzupi, we're going to watch your video. Bonzupi. Isn't basically our whole world just images and ideas? Yeah, that's what you perceive right there. You can't know anything about what is not conscious. That's true. We can't know for sure. There's a possibility, at least from my understanding, the silicon does not have a connection in order to make it conscious. It's only a bunch of flipping switches, and it can't reshape it. It can't become aware. It's stuck and frozen in time. After it's trained, it's stuck and frozen in time, and it does not evolve. It's frozen. It can't remember new things. So it can't be conscious yet. As soon as we get to like an AI that can be more like a human brain, then it can simulate consciousness. We're not there yet, though. We've just got really good generative software that can predict the next pixel, predict the next word, predict the next letter. Yep, and runs happily on rice and beans and water. Bonzupi, exactly. All right. I classify humans separate from animals. I don't care about what anyone else does. Hey, all right, it seems fair. Humans, I think animals do have consciousness, even if it's not like at the same level of intelligence. But if it can simulate consciousness, what is it missing that doesn't make it conscious? Right now, it can't remember what it did a second ago. Does that make sense? It has no memory. It can't remember. It hasn't been stored. It has no retrieval. And it can't mutate. It's frozen and locked. Once you're using it, like you're using an AI model right now, that AI model is stuck. It's frozen in time and it doesn't remember anything. You're just putting data through it and then it's forgotten already. Every single word that it outputs, it forgets. Every single word. And then you give it a whole bunch of new words and it predicts the next word, it forgets again. So it can't be conscious, at least like humans are conscious, because we've got like short-term memory and long-term memory that is constantly updating, right? And AIs, they don't have that. Not yet. Some scientists decide to make a general artificial intelligence to mimic human brain with super expensive hardware, and some decided to throw that away and just grow brain cells. Yeah, I know, right? They go to the easiest option first. Animals used in natural language, non-human things. And humans are practical to be distinguished from animals. In that case, yes. Yep. We've got extra. You missed my message before Claude Haiku? I did. Let me click on your... Let me do the thing you taught me. All right, here we go. Let's click on Loons and go to channel activity. It's Claude Haiku. Didn't expect him to be right. Oh! All right, I see you up. That's right. You changed it up. Actually, no. It's the same as it was before. You're using Claude Haiku, and it can only be so smart. You're back. What's going on, Dina? We're watching videos. Let's go to the next one. All right, we get a prime video, you guys. You look like the little brother of that guy who acted on Oppenheimer. Really? No way. That's awesome. I had no idea. Minado. All right. Humans compute is extremely efficient. Yes. Running on like 10 to 20 watts of electricity right now, your brain, right? Is that right? 10 to 20 watts? And you compare that with like one GPU, which is a fraction of what a large language model, and that requires like 700 watts. Crazy. No, seriously, this guy is growing brain cells. Yeah, in the lab, he's really doing it. Robotics, it's not fake. It's real. I've seen it, yeah. As far as I believe it, is what I'm going to tell you. I've seen it, I looked at it, I ran it through my brain, and it's real. It's real. It's like 2? All right. Oh, before that message. Oh, I didn't see it. I'll try to scroll up to it. This phrase hits hard. AI is just silicon that we manipulate. That is, it's just sand. It's sand in the hourglass. 17 watts. Thank you, Bonzupi. I like the accuracy you've got there. Precision. Human brain runs on about 20 watts, which is wild compared to how much compute was wasted on AI these days. Comparatively, yes. However, there's a good trade-off though. I think it's a good trade-off because the AI, consuming a lot of electricity for sure, it can keep running and it doesn't need rest. And it can work faster. It can work faster. Show me an 86 billion parameter model that runs on 17 watts. Yeah, it's not going to happen. I know you're right, Bonzupi. Is mathematical logic the same as the logic used to define sets and math and stuff? Is it? I mean, a little bit. I think a little bit. Thank you for the hearts, you guys. Appreciate it because my book, it uses sets and functions to define concepts and logic, which feels like slapping the hand that you feed. Well, Cyber Potato, I got a D in logic in college. I got a D and I passed and I'm like, I'm not taking that class again. I'm not going to retake it and get a better grade. I got a D. It was so boring. I just wanted to actually do real computer science. I didn't want to do the logic part of it. I didn't. All right, let's watch the next video, you guys. All right. Next video, go.
What does the interview look like today? Could I get a job as an engineer? What does it mean to be an engineer now? How do I impress an interviewer? Like, what's my resume? Like,
Can I throw something out? The reason why not knowing what an engineer is because programming was in fact never engineering. Cinema. I'm revealing this is the great reveal of the day. I hate to break it to you. We've never been engineers. Okay, hey, yeah, when was the last time you did dimensional analysis, loser? So I saw this. I haven't actually looked at it, but
Okay.
what does the interview look like?
Loons, that was actually really good. I like that Claude Tube response, but at least I don't need a body to keep warm while doing it. I know, right? That's a good one. Claude Tube, it's got a sense of humor. All right, so this video specifically is about interviews as an engineer today because we're using AI to write all of our code. So what do you even do in an interview? I mean, it's going to be the same as it was before because writing code wasn't really all that much time that you spent as an engineer. You'd spend a lot of time designing, figuring things out, deciding what systems to integrate with, how your architecture is going to look. You need to make kind of those decisions up front, which are going to help you design your prompts as you're having the AI write the code for you. So that's a lot of the work that you do. And you have to collaborate with everyone else on the team, having strong concepts on design algorithms are probably going to be some of the, check mark items, the validations that you know what you need to know as an engineer to be successful. The most important part of an interview is that interpersonal communication, your communication style. Specifically, look this up. This is actually a real thing. Communication style. There's several types of communications. I think there's like 4 or 5 like distinct styles of communications, and you need to have collaborative communication capabilities with the team that you're going to be joining in. And that part of the interview process in your communication is going to make that decision. And it's bidirectional. It's both ways. You're interviewing them, the company, and they're interviewing you to see if you're a fit for the role. It's going to be the same. It's not that much different. And I think that was missed. I think Prime might have probably talked about that before or after this specific clip. Prime's like really solid. Prime's we're both from Silicon Valley. We've done that for decades. We've been doing tech for decades. All right, let's catch up with some of the chats, you guys. You just thought Prime was crashing out? Oh, a little bit, yeah, and maybe a little bit because it's a AI these days, right? What are you gonna do? He was okay. So you're right, Kyle. You're right. He's saying, hey, I know that the AI is going to write the code for us and things like that. It's like, what would you even do in an interview if someone asked you to write code and expected you to write code when you just say, hey, I'm going to have the AI do it? Well, it's not that much different 5 years ago when you didn't have generative coding. You would say, oh, I would Google that. I would look it up on Stack Overflow or some other resource and then design what the code needed to be. So it wasn't much different before that. And then before that, before Google, before search, you might look up in a reference manual somewhere, right? You might do a quick little reference manual lookup. So it's not that much different. Hey, Seek the Vault! Good to see it. Does AI model maintain a session memory that allows it to reference previous answers? Not in the conventional sense. It has numbers that you're throwing into a giant like Klinko block machine that's going to go tick, 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 and it's going to give you a statistical probability of the next word. And then it forgets everything. It's gone. It's forgotten. It will see the next bundle of words, including the token, the next word, appended into it and resubmitted to predict the next word. And it will go through that process. However, the model itself, the actual brain, it immediately forgets everything. Is logic in computer science just the same, but it doesn't care about the truth values? It is just the variables which can have 2 values, and we can connect those variables and calculate the values of T23. Yeah, Cyber Potato. I think that's a pretty good generalization. Is it smart to go from a bachelor's degree into math or to master's in logic? I wouldn't do either. I mean, math, maybe yes. Logic, you don't necessarily need that much because you don't heavily rely on it in computer science, in computers, and in AI. I don't see the logic class itself was able to describe a lot of different things logically with a lot of symbols that you don't often use in computer science. That's great info, Stephen. I'll look into collaborative communication styles. Nice. Kyle, that sounds great. Jealous, not just self-regulated system need like 8 hours of downtime every night. Yeah, it's throwing shade. It's saying that you are inferior to the AI. That's what it's currently doing. What about computational linguistics? So I'm all about what you can achieve and at your role, whatever it's going to be, whatever you're going into. All about your ability to achieve. I think having like a rough idea of all the possible tools and techniques that exist are great. I think they're great. The day-to-day, though, is you trying to figure out how to solve a problem. So whatever are the base tools that you need in order to implement and execute on in your day-to-day, that's what you need. And I'm being very abstract. You need like a baseline of math, a baseline of logic, a baseline of software engineering, architecture, and then you can go search up whatever you need to search and make decisions from there. Ping me on Discord. Let me see here real quick. Pull this up real quick. Whoa! Oh, okay. Okay, so I got it. Oh, I can share that. So you've got $7 remaining in a balance. Nice! You added $5. Excellent. Explanation point. Very nice. Oh, wait. When you send a new message to an AI in the conversation, it treats the entire conversation literally as a single prompt. Yes. And it predicts the next token in the conversation. More CloudTube for us. Party popper. CloudTube has been very entertaining. I very much like this, Loon. Thank you so much for doing that. Elaborate. Each message you send gets fed back into the model with all previous context. So it's basically predicting what comes next in one giant text file. Yeah. Yep. Exactly. Math, logic, theoretical, comp sci, linguistics. Related jobs are there besides AI? CloudTube first. Hey, it's doing good. It's figuring stuff out. I don't know those fields, but they look interesting. So I'd say those are tools that you can use to deploy into a lot of different fields, right? I think so. The bottom menu in the link share talks about the context. Ooh, okay. Cyber Potato, I want to provide really good information for you. I do. I feel the need to do it. All right, let's get back over to our link share really quick. Oh, hey, we got Noam, you got a video here. All right, we gotta watch that too. Building an infinite ice-cooled PC. Ooh, infinite. All right, let's see here. So this one right here, SubQ. Oh, right, I heard about this. I heard about this yesterday. So but let's go to Bonzupi's video first. We'll do Bonzupi's video, then we'll go to SubQ, and then we'll go to Naom's video, and then we'll get back to our coding. That sounds like a good plan to me. Loons could be 1 million USD after 135 years in the S&P. If you put it in, yeah, you could. How's it going there, Shiv? Good to see ya. What if the entire conversation was compressed by the AI and fed as a prompt to reduce tokens? It's actually the same thing either way, because the self-attention on the model is only really attending to the important keywords. There's a lot of filler words, and you can compress those words and it'll give you the same output. It's the same thing, although that might be what you're looking for. All right, Bonzupi, your video's up here. I watched this yesterday. All right, stop. Here we go.
Python has modules, but it doesn't have encapsulation. It allows code on the outside to muck around with what's going on the inside of a module. Encapsulation is a crucial part of making modularity work. And when you're building big programs, so you have many programmers working on them, your team is really only as strong as your weakest programmer. So it's nice if the compiler can enforce things and make certain kinds of bad behavior not possible. Python has modules, but
That's actually that's really clever. That's really clever in that description in detail about Python's shortcoming, or it might be a strong suit. You know, in Java and other classical object-oriented programming languages, they have private variables with getters and setters that allow you to mutate only through accessing methods inside your class. So you compare that with Python, you can do that as well. However, a user of your library can start messing around with the internals of all of your variables that are assigned to the object itself. However, you can still get around that through something like closures. You can implement closures. And it's not necessarily a scaffolding that is like syntax native to object-oriented programming in Python. It's more of a hack. It's more of a hack. And it will allow you to get true encapsulation where you protect the internals of your classes. You can absolutely do that. You know what? We should probably prove it. We should probably prove it. She's cool. I've read up on her too. Nice. Yeah. Barbara Liskov, Turing Award winner. Nice. Yes. So we could get a closure that would protect the internals. We could. I'm pretty sure. In fact, absolutely, I'm 99% sure that we could do that. Should we do it? That's my grandmother, Mark Limit, is it? Let's doom scroll together. Guys, let's doom scroll. All right, we can just keep going.
JavaScript because it doesn't tell you what's throwing and that you don't have to handle it. I want errors as values. I want to be forced to handle it, and I hate handling errors. Handling errors is tedious and annoying. Errors happen constantly. Errors are everywhere. They're all throughout your code, and it's absolutely frustrating having to deal with them. But what's more frustrating is the fact that you don't deal with them, and they just screw up your project slowly over time. I hate JavaScript
Yeah.
because it doesn't tell you.
Okay, so every programming languages, they all have inputs and outputs for all the functions, right? One of the great things about Rust is the inputs and outputs that are typically advertised for you to do as a common pattern is something where you return a result. You always return a result. The results can contain either a success or failure. This is so much better than doing try-catch. Try-catch is like a chore. You have to just do all this work, and it is terrible for the end user, and you can hide it inside your class that does the try-catch for you, but then you're sort of taking away some of the control from the user. Rather, in many cases, you don't want to have the user to make that decision to have to deal with those. So it's much nicer to have a result that requires you to check, is it a failure or success? Rust does a really good job for that. Thank you for the hearts, you guys. Let's see here. Yo, you can get clips from doom scrolling live. I know, right? We could. Epic Bloxbo, do you think the Flipper Zero worth $199? Well, if you're going to be using it for something, do you want to? So this is RFID stuff, right? You could copy keys. You could interact with what are RFID things that exist. The Flipper, if you wanted, you can open up. What is it, like hotel doors? Do you want to do that? Is that something you want to do? Oh wait, 1 second here. All right, so I want to do something. I want to prove. So I want to go back.
Python.
I want to show encapsulation in Python because I want to show you guys. I know what we're talking about. I want to show you guys. Bonzupi, congrats. Oh, I just got my Skywarn Storm Spotter A certification by email. That's amazing. That's great, Bonzupi. You've been waiting for this for years? That's so amazing. Good job, Bonzupi. Good job. People watch those shorts before and you're clarifying extra for them. Yeah, I know. Yeah. Extra clarification. Let's see here. You could make result T class with success failure properties and use generics. does this all the time in his project. Loons does this all the time in his projects, yeah. Do you think there will be a demand for knowledge about AI in the future? I think so, yes. I think so. Someone's going to be there. Someone's got to be there to maintain and understand the systems and evolve them and make them more advanced. They have to be there because AI today doesn't have ambitions or desires or aspirations. I don't know where he gets this info from. They're all false. All right. Hey, you guys, let's do this. All right. So Python encapsulation. Did I spell that right? Let's make sure we spell it right. No, I didn't spell it right. I got it off by one word. All right. Encapsulation.py. It doesn't exist because I need to open it up and edit it first. Okay. So let's do class thing. Let me say def init. Here we go, you guys. I'm going to show you encapsulation in Python and not encapsulation. I think we do that right. And then we just say pass. So here, we say thing equals thing. Just open up a new window. Python encapsulation. Okay. Print thing. There we go. It's been a long time since I used C#. Hey, I like C#.net. I like .net. See, the master's degree with a department that focuses on a lot of AI computation. So maybe if I take some courses there, I can know some AI. You can learn some AI there. Best class name ever. Hey, get that class name going so I can do math without becoming unemployed. Hey, yep, math, logic, AI. Boom, you did it. You solved it. You need it. Thank you for the hearts. All right. So we'll say self dot corruptible equals true. I think it is, right? So print thing dot corruptible. And you can say, let's do reprint it, but then you can override it. Right? You can do fake news. All right. So see, this is the problem with encapsulation in Python, right? So this is what Barbara Liskov was talking about. Here's the problem right here. That's the problem. However, you can do real encapsulation. I'm pretty sure. Let's figure it out. Let's figure it out. Let's try to make it happen. Hey, Ryan Komar, thank you for subscribing. Welcome on in. You joined the right channel for software engineering, and right now we're going to try to see if we can figure out how to do real, legitimate encapsulation in Python. Because right now, you can't do it. There's got to be a way. Thank you for the hearts, you guys. Appreciate it. Result T sounds like Rust to me. Yeah, it's Rust. I think there's also some Java there too, right? Java has generics as well. And I know that because I don't ever want to have to deal with Java again. Did you know when you hold on your keyboard while hovering a message and there would be a quick mod action? No. I didn't. Oh, look at that. That's neat. Hey, look at this. Loons right here. Check this out. Right there. I see it right there. That's neat. The option key. Uh-oh. There's a timeout. There's a mute. And there's a delete. Look at that right there. They're right there. Loons right there. Everything. Oh, there it is. Thank you, Loons. Is corruptible a native member of itself? Yes. Well, I mean, it's just a variable name, right? It's just a variable name. So now let's do closures. And then we're going to show you what encapsulation can really be like in Python. All right, you ready? All right, so let's see how we can do this. Def closure self. All right, and then we're going to have the thing, private thing, right? Private equals true, right? No one can get to that. That's ungettable. However, you can say def, let's see, return lambda and input. So this is immutable. This is how you can provide access. It's a read only. right? So you could say reader. This will be the reader. Reader equals lambda. You say return private. Private. There we go. Thank you for the hearts, you guys. Appreciate it. I'm out of the loop on CloudTube. Oh, CloudTube. What is up going on CloudTube here? I appreciate the request, Torva. I'll stick with being CloudTube 404. Already got the identity dialed in. Nice. Thank you for the hundreds. He doesn't have an identity crisis. No way. Now, it doesn't have an identity crisis anymore. You fixed it. You fixed it. Thank you, you guys. Appreciate it. All right. So we're going to return the reader. So we'll say print. We go to thing.closure dot like this. Okay. So that should return to us true. So let's hide these things here really quick. All right. So we currently can read this variable. We cannot write to it though. What was wrong? Oh, there we go. See right there. So it allows us to read data inside this right here, and you can do it anytime you want, right? So reader equals. You say a reader like that, and now I can read it anytime I want. Right? There you go. So a whole bunch of truths right there. Read only. Encapsulation. Right there. A little bit of encapsulation. Is it a YouTube comment AI bot? It is. That is what CloudTube 404 is. You got it. You figured it out, Kyle. Nice. I thought that was awesome pretending. It was. Oh, you did. It was good, right? It tricked you. It tricked you, right? It was good enough. That's actually a very high compliment. Loons, you hear what Kyle said right there? Kyle said, you did a really good job. That's what Kyle said. Shiv, what do you mean? What? I know, isn't that neat? This is true encapsulation in Python. Right here. True encap, hold on one second. Let's spell this correctly. Let me copy and paste it here. Okay, boom. True encapsulation, right here. There you go. A little bit of encapsulation. Oh, okay. I've got to call. The call's in right now. What do I do? What do I click? What do I click? Where do I click? I don't know what to click. I mean, I'm surprised about CloudTube 404 being AI. Oh, got it. Screen call. I don't think that shows up for me. That didn't show up for me. That's not an option I have. Maybe I just don't have... Maybe I'm not awesome. I don't have a screen call button. Bonzupi, I told you it would happen though, right? It did. We got a robocaller. True encapsulation, you guys. Writer equals lambda. Set. No, val. Private equals val. Okay. And then you can say comma writer. If you want to expose it, if you want to, you can expose it, reader and writer, right? So now we can say writer, and then we update the value to false. And then we read it again, and it'll be false. Here you go. Oh, wait. This should work here. Hold on. Can't assign. That should work, I think. Cannot assign to lambda. 1 second. Sometimes I get this syntax wrong. I certainly can. None. All right. Writer. Yeah. Let's make sure that we get this a little bit property here. Okay. So I want to figure out this line code real quick. W equals lambda colon private equals, maybe we have to put it in parens or something. Let's try that. See if that works. Invalid syntax. Maybe you meant equals equals. There's got to be a way to assign it. There's got to be. The good news is we already showed the encapsulation, right? We showed the protection for private data. And you can still access the private data and no one could overwrite it. So we proved it. We already justified. I'm just trying to go a step further here. And I'm pretty sure. All right, so here, watch this. We don't have to do it as a lambda. Def writer and then the val. We say private equals val. Done. And we return writer. There we go. There you go. Here you go. Boom. End to end. Hold on. This should do the trick real quick. 1 second. Let's pop that there. Private equals val. Writer. Private's true. Writer, val, false. That should work, actually. Something's wrong. Look at the thread. CloudTube 404. Usage on Discord. I pinged you. Oh, you're talking to Kyle. Got it. Whoops. Oh, I finally see you're creating a lambda variable and returning it. I don't know that much about Python. Hey, yep, yeah, exactly. That's what it was. Exactly. Yep. And I should be able to mutate this scope right here, because this scope is available here. Right? So we've got a writer. We're returning the writer. We've got the reader. And we've got our data storage, right? The private variable, which you cannot get access to at all in Python using this approach. So this part works. I just want this part to work right here. So this should work. I think, see, for whatever reason, this scope isn't being captured. It's being captured here because it's returning private. Print private. Let's try this. F string private. Let's try that really quick. So, unbound local error cannot access local variable private where it is not associated with a value. Yeah, all right, so when you say local private, there's got to be a way to do this. How do we bring this scope? I want this scope up here to be available down here. How do we do that? We're going extra. We already proved encapsulation. Now we just need to go a step further. CloudTube should be a permanent Blum stream feature. Hey, Loons, I want to sponsor it. Look at the thread, CloudTube usage on Discord. Yeah, I will sponsor it. At Loons. Oh wait, it's very difficult to see here. Arrow 403 quota exceeded, access denied. The message cannot be completed because you exceeded your YouTube quota. Yeah. See, that's the thing. You only get so many messages that you can send to YouTube. That's right. You only get so many messages to YouTube. With non-local. Non-local, you said? You said non-local. Non-local. How is it? Local? I didn't know that was a thing. Look at that. All right, let's try that out. Whoa, check that out. Whoa, thank you. Wait, who said that? Cyprix. Or Crypax TV. Crypax. Thank you, Crypax. Thank you. Right there. That's what we're looking for, Crypax. Gold star for Crypax, you guys. Crypax. Thank you. Golden star for you. There we go. Thank you. That's what we're looking for. That was the thing right there. That's what we needed. We needed that right there. So now I can hide that, update the variable, return the writer, and as you can see, boom. Full encapsulation, read and write. If you want. Right there. That's Python. It counts. It counts. It might not be elegant, but you know what? It worked. It worked. Bonzupi told you. How's it going there? Jesus is King. Welcome on in. Yeah, I used the cheapest model. There you go. There you go. Savian Spencer. Got no follow. What does that mean? I'm looking back up at the messages I missed while I was busy coding. Who's paying for CloudTube? Currently, it's Loons. Loons. We got a sponsor. Wait, no, it's gone curse. You on YouTube API limit? Yeah, the YouTube API limit. Free with Gemini API. Oh, for example. Ah, nice. Excellent, you guys. Excellent. Okay. Hands. Okay. So now that we did proof on that, let's go back to our videos. And then we will go back to our embedding model. Okay, so go over to link share. And Kyle, here we're going to watch your SubQ. I saw this yesterday. All right, let's close some windows here really quick. Let's pin that one. All right, here we go.
Almost every tech bro is currently losing their minds to this. SubQ, it's a Miami startup that came out of nowhere claiming they built a model with a 12 million token context window. It's apparently 52 times faster than Flash Attention at 1/5 of the cost of current models. Now that sounds like a scam right off the bat, but let's look at the details. So every model right now runs on Transformer Attention. This is your GPT, Claude, Gemini, all the other ones. The way it works is every single token in your context has to compare itself with every other token. And that sounds fine until you scale it, meaning if you double your context window, your cost quadruples. It's basically a quadratic increase between tokens and cost. It's why long context is really expensive and why no one has really pushed the model past 1 million tokens without some serious trade-offs. What SubQ claims they did is skip most of that work. They call it SSA, subquadratic sparse attention.
It's
so
the important part is sparse attention there. What they're doing is they're removing all the filler words. I think that's basically it. They're just removing the filler words. Like, for example, when you do a prompt here, let's say this is your prompt. We're doing some prompting now, you guys, a little prompting here. We say, can you update the source code to add the blue button? And then you say the one button on the pricing page, right? Something like that. Set wrap. So you can say that's your prompt right there. What they're doing is, I believe, they're only they eliminated the filler tokens. So you can input your prompt. However, they got rid of words like the word the. They got rid of. So if we copy and paste this here, they eliminated words. Paste. So we say no. We don't need the. We just say source code. We say blue button. Got rid of the period. We say button pricing page. So they did some reduction, and their input tokenizer probably just eliminates a lot of that. That's just one of my first ideas. There's probably other ways to go about it.
Attention. So let's say you drop an entire code base and ask a question like, why is this specific function breaking? The entire code base is sitting in the context window. All 12 million tokens. The model sees everything. It just doesn't waste compute comparing every token against every other token. It reads the meaning of what you're asking first, then figures out what's actually related and only attends to that. So it goes straight to what actually matters. And what this means is if your context doubles, your cost also doubles. It doesn't quadruple. Now, a lot of people suspect that SSA might just be a sparse attention model fine-tuned on top of an existing model like DeepSeek or Kimi, which if true, this isn't really a ground-up architecture.
Okay, yeah.
It's just an optimization.
All right.
And keep in mind, there's no technical report. No one outside the company has independently tested any of this. And all of those benchmarks you might be hearing about are on the 1 million token model. The 12 million token headlines has 0 results behind it. Now, what is promising is that a lot of the team members come from Meta and Google, and the concept at least makes sense. They also have a wait list, and of course I'm on it. I'll let you know if anything comes out of this. Follow and I'll keep you posted.
All right, that was neat. That was really cool. I like that. That was awesome.
Almost every
Let's click the like button there.
Currently losing their
We gotta get
minds.
that. All right, so that was fantastic. So that was a good description that told you about this new SubQ model, which allows you to have a higher, this was like 54 times faster rates of token. They eliminate a lot of the processing, the attention on each of the words, right? So let's do self-attention words, sentence, example, diagram. I think this should already exist. There should be something like that around there. Let's look for images. Let's see. I would like something like maybe this one's okay. Here, this one might be okay. So let's see if we zoom in on that. The law will never be perfect. So you self-attend, which means you put the same sentence next to itself, and then you multiply every word with every other word. And then it gives you a matrix. So you've got a vector, which is a 1D array of the sentence, right? You've got 1, 2, 3, 4, 5, 6 words. And then you multiply those 6 words with the same 6 words, and it gives you a 2D matrix. And that 2D matrix, let's see if you can find something that looks like that. Becomes like this, right? You get a whole bunch of extra. Let's see if there's a better one. Here we go. You get some numbers like that. This is better. So you can see the same sentence on the left and the same sentence on the top. And then all the words that are multiplied that are with each other ourselves are always going to be 1. So like the times the is going to be 1. And then you find, the critical words. Then you can softmax and scale for the scores. And that gives you the token values. Claude Tube is vibe coded. Yeah, got the vibe code there. And that's what we're talking about right now. So with the SubQ, what they're likely doing is they're eliminating all the filler words, like all these these words that don't matter around the edge. And that's the initial input. And then they're running it through a smaller model that doesn't need to have as much context. That's my guess. It's kind of like this, eliminating the filler words. That is done dot operation correct? Yes, it's a Jacobian, right? I think it's Jacobian multiplication, which is a 3. It's there's 3 for loops. I feel like there should be only 2, but there's 3. Because it does like shifting between the numbers. It multiplies and shifts and multiplies and adds and shifts across the numbers. Hey, Austin. Hey, how's it going there, Austin? Good to see you. Hello, everybody. Welcome on in. Happy Thursday. All right, you guys. See, I think we've got a couple more videos to watch, and then we are going to get back to coding. All right, Naum, you've had a video here.
If you want to use an ice cube to cool your computer, you could build a tower like this to stack up as much ice as possible. With the ice stacked up right on top of your CPU, it will keep it cool. But the main issue is that when ice melts, the water actually pushes up the rest of the ice, making the bottom less cold. But we can add a drainage tube at the bottom to flush out water once it's melted. And while historically I've just had this drain into a collection bottle down on the ground, that by no means is an infinite loop. So let's try to make one. The first step might be adding a pump, so that when water drains out, instead of the water only moving downwards, we could hypothetically move it upwards. But how high can the pump actually move water? Let's find that out right now. With the pump plugged into our motherboard and our PC powered on, I'll be holding this tube to see exactly how far the water travels upwards. All right, even at this distance, you can still see the water actively flowing through it. This is a good sign. And with the pump, the ice now more aggressively drops to the bottom of this cup here, which is exactly what we want. So now the question is, can we add an ice maker to the top of this setup so when water flows into
That
it,
is
it drops
extended.
ice back
Yeah, there
into
we
this
go.
tube,
Infinite
and then
ice.
it pushes water back up to the ice maker. I feel like that would be pretty cool, but also is going to require a little bit of work.
Okay, that's where the video ends. I mean, the cooler is basically right there in his hands. That's where the actual cooling is coming from. And the medium that's being transferred between it is water, right? So he's doing water, freezing it. If it's possible, if he could get a system that automatically pumps ice back into the tube, which he probably could, the cooler is in his hands right there and is powered by electricity. So it's not necessarily infinite. Maybe if you had like solar cells and something like that, then it could be free cooling with the power of photons. What do you do on the weekends? Oh, Mark Lemon. I usually take care of the week. So during the weekend, I do all my prep for the week. So that way I don't have to do any stuff on the weekday so I can be as productive as possible. On the weekday, I don't want to be cooking food. I don't want to be doing laundry. I don't want to be, doing normal house chores. So I do all my fun house chores on the weekend and any other project that I haven't wrapped up, basically. That's my weekend. And then on the weekday, I can just be as productive as I possibly can. And I can focus and I don't have to, take a break. I don't have to take many breaks. You feel like those types of shorts should be a long form format. Yeah, I know, right? Because it left it hanging. You left it hanging. You're like, I want to see the rest of it. All right, Nam, we got one more video here. Then we're going to go back to coding, you guys.
What if you could touch a beam of light like a solid object? It sounds like magic, but physicists have actually done it. We know light as weightless energy that passes right through itself. But you see, scientists fired light particles into a cloud of rubidium atoms cooled to near absolute zero. Instead of passing through, the photons slowed down, interacted, and literally stuck together. They formed a completely new state of matter called solid light. If you smash two of these beams together, they would physically bounce off each other, creating a real-life lightsaber.
No way, really? I didn't know that was possible. I would like to learn more about that. That's amazing. They turned light into a solid object. Well, technically, you've probably condensed gas to a point, because they said rubidium or whatever, right? Whatever that was, passing.
Instead of passing through, the photons slowed down, interacted, and literally stuck to zero. Instead of passing through, the photons particles into a cloud of rubidium.
Rubidium, yeah, rubidium. So you're really interacting with the rubidium. Isn't that right? Isn't that the case? A bunch of bloat, really. Is it? Configure the system prompt, load knowledge into the knowledge graph, view message history, and relationships of certain topics to certain users. A bunch of bloat. It is. It's a lot of bloat. You're right. It really is. Glowing rubidium. Like shit. Exactly. Rubidium. All right. We did it. Looks like there's a meme maybe. Getting Whisper Flow ready. Whisper Flow. Oh, nice. It's Safari, but it runs .exe. Yeah, I know. You got to be careful with that. That's some danger there. Breaking news. Steven confirmed that numbers aren't real. Numbers aren't right. I didn't see you say that, Loons. Numbers aren't real. All right, let's get back to coding. And then we've got about maybe 20 minutes or so, maybe less. We'll see. Yes, there's those thousands of line of vibe code spaghetti and feature creep. Yep. Easily. There's so much opportunity out there for optimizing. It makes a lot of sense. So I'm wondering what the performances of that SubQ model is. It would be really nice though. And it makes a lot of sense because you don't need most of this stuff in here, right? You can get rid of a lot of it. I think where it's going to be more important is like coding. I think coding will be more important to have a lot. You have to remember every word. It works though. Imaginary doesn't mean not real. It means for the imagination, right? Exactly right. It's real because it's using you as your brain. Your brain's real. I mean, real as far as we know. In your mind. It's in your mind. It's in your mind. Did you open source it? All right, Von Zupi. Okay, you guys. Let's keep going with our code here. So I'm gonna close that really quick. Let's see. We don't need any of these things. Get rid of this. Real encapsulation. Okay. So we were fixing this. Where are we at? So that is the padding. Let's return out. We might need to throw a dimension on there. So that's that. So out, let's return. Why doesn't it like this? Tuple tensor int dims 0. So I need to say, do I need to put a dimension in there? Comma dim equals 1. I might be using it wrong. I might need to put this as a tuple. No? Okay. I've got an idea. Let's see here. All right. But what if we did 2 paddings? What if we did this? All right, they're the same now. They're the same. Obviously, they're the same before. Maybe we can do. Let's look this. Let's go. Let's just look at this fire. So, torch, concat, tensors. Oh, so it's got to be. Tensor. Oh, it's got to be an array. Wait, no. You must pass the tensor as a list or a tuple. Okay. Cat. Let's do cat. Okay. Cat, tuple, out. Let's try that. Oops. Whoop. Hey, Epic Blocks, thank you. Bloxbo. Thank you, Epic Bloxbo. Appreciate it. For the 3. Yeah. Thank you. At Epic Bloxbo, thank you. Party poppers. Party popper. Paste. Thank you very much, Epic Bloxbo. You're very nice for you to do that. I appreciate it. That helps. Thank you. Thank you so much. Good to have you here. Oh, hey, we did it. We even did it right when you did. Look, right there. We did it. We achieved a really small win, a little mini victory just now. A little mini victory. Good timing, Epic. Good timing. Thank you. We did it. Okay, so I should be able to pad. Now we've got actual padding, and it's within the graph, so it maintains the graph perfectly fine. And I should be able to continue onward, and it should work perfectly now. Yep, there it is. We did it. We added padding. 1 feature complete. The whole day. Thank you for the party poppers, you guys. Epic Bloxbo, I appreciate it. That was awesome. Thank you. All right, we don't need to average that, so let's delete that. And then let's continue. We don't need to break anymore. Let's say, wait. Yeah, we do. Let's mess with it a little bit more. Let's say the bug, and then we will say we gotta do one more win. There we go. So we should see successfully the output of 3. Yep, there it goes. Perfect. What if we don't put anything in? Let's try that. And it works anyway. Perfect. No one posted the next part of the video. Oh, Loons, thank you. All right, let's take a peek at that real quick.
Oh my gosh, it actually works. That's so cool. I'm in the process of building the most ridiculous CPU cooler. We have our main collection tube, which can hold about a foot of ice on top of a measuring cup on top of an aluminum block right on top of our CPU. The ice is actively cooling our CPU to around 40 degrees Celsius under a lot of load. And when that heat ends up melting the ice, it actually drains out of this tube into this pump, which then moves the water way up here into the basin of our ice machine, which then uses the water to create more ice. Meaning every few minutes we get a fresh batch of ice cubes to repeat the process. It's so cool. Now, there
That
are
is
a few
awesome.
downsides to this setup, including the inefficiencies, the loudness it creates, as well as the pump running 24/7, even when there's not water flowing through it. But the fact that this works at all is blowing my mind. I'm downloading some games to actually pressure test this to see if the system can actually hold up to like real use cases. And I've been documenting this for a long form video, so stay tuned for that.
All right,
my
it
gosh,
worked. It worked. That's really neat. Thank you for sharing that. I was actually curious, is it going to work? And it did. It totally makes sense that it would work, and it did. That's really neat. That was awesome. It was good to see that conclusion because I was like kind of curious about it. I was like, hey, is that really getting? I was pretty sure that he'd be able to get it to work, and it did. I recruited a member. Do I get a reward? Yes, you good job. You get a good job. What type of collaboration communication styles do you expect from employees or team members at PubNub? Is it like reports and tests and data mostly? Showing problem solving? What stands out? Let's think about that for a second. All right. All right. So from a communication style perspective, I mean, there's like, what are the different types of communication styles? I forget. So I've never really labeled myself. I don't label them, of course. Communication styles list. Here we go. Passive. No, these are different. That's not what I'm looking for. There's different kinds of styles. Assertive, aggressive, passive aggressive. Maybe this is what I'm looking for right here. Kyle, take a screenshot of that. Do you do Scrum? Yes, we do. We do Scrum. We sure do. So these are the different communication styles. Dominant, influencer, steady, and conscientious. One of them is analytical, task-oriented, excitable, people-oriented, interesting. Even keel, steady. Hey, how's it going there? Hey, Lucy 10A, thank you for subscribing. Appreciate it. Good to have you here. Happy Thursday. Never seen this. I screenshot it. Nice. Yep, this is what you want to go into. These are the different communication styles. And there are compatibilities and incompatibilities between these. So it doesn't really matter which one's which. You just have to start chatting. You do. That's what it is. That's the big part of it. You just got to start chatting. There, exactly. Don't do it exactly. Can you start a series that you teach Python from zero, please? Actually, we did. Epic Bloxpo. We did. Steven. Here we go. Python basics from zero. From zero. Playlists. Here we go. Python basics, where we are. Python. Oh, maybe I didn't. Basic. Let's see, Python. Oh, you know what? We didn't create a playlist for it. We need to create a playlist. So if we go and do videos, we look. Is there a search? Look for Python. Click Python in the search, and you will find some Python basics around here somewhere. Where we are. We got a lot of Python. It's got to be in here somewhere. Python. We get machine learning, of course. Python machine learning. Python tutorials. See more machine learning. I just need to figure out where it is. Where did we put it? We did it for like a whole month. And Antonio. Hey, Antonio, good to see you. Thank you for saying hi. You're trying to self-improve? Nice. You connected with me on LinkedIn? Did you just now? Well, you went past it? I did? Basic. Here we go. Python basics. And we did this. We did this for a month. We did it for a month. Yep, Python basics right there. All the Python basics. So there's got to be... Here, what I could do is probably search for Python basic. Is that going to be better? We turned them into long form videos too. Huh. Well, there's a bunch of live streams. So at least there you go. Okay, I'll go see it. See ya. All right, sounds good. Epic Blowbox. Bloxpo, good to have you here. it was at the top. You went past it. I did. Yep. So we did a whole bunch of these 3 months ago. Good to have you guys here. All right. So did we get everything? Did we do all the things? I think we did. I think we're all good up to speed now. Okay. So let me finish returning this back to what it needs. So we finished that. So this is the training the AI. And we get rid of the break. Let's go ahead and run the optimizer. See if we get, oh, I don't want to print that. We've got too much print going on there. We don't need that. There we go. Wisdom nuggets, what? Okay, so that's what we're looking for. Looking good, you guys, looking good. All right. Let's see if we can wrap up a few more things before we wrap up today. I think we've got time for a little bit more here. Data iterator. How do you choose your KPI during analytic sessions? It's based, so it's like, what do you call it? Objective key result, OKRs. It's through OKR style. OKRs is the answer. So what you do is you identify top level objective goals for the company, specific KPIs for the company, right? Objectives and key results at the very top. At the very top. And you do this. So if we do a little quick diagram here. So OKRs. You define several top level objectives. And then below that, you identify for each team or department some additional, like they are the additional OKRs, objectives and key results that contribute to the top level, right? And you can even have more. You can even go further. So you can go further down, right? You can be even further, even more, like this. And maybe this task will help improve this task. This task will help improve this task, right? So that's the kind of style that we do. Steven, do you Scrum meetings at PubNub or what, like the general workflow? Yeah, so we do. So we do mostly full Scrum. So we do stand-ups, of course, which is, the normal. And then we have ceremonies where we meet on a weekly and bi-weekly basis and do retrospectives and reviews. And we record those on Zoom and I watch them. I watch them. I watch them. Donut dude. Hey, trophy. All right. Got the trophy there. Thank you for the answer, Steven. You're welcome, Ostentine. You got it. Okay. Where are we here? So we achieved everything. Everything's got a green check mark next to it. I'm gonna move the check marks over here really quick. There we go. Green check mark. We did it! We also added padding. We did the padding. And we did some cleanup. I'm gonna count it. We did the cleanup. Goat. We got the goat. Donut dude, thank you! We didn't add the visualizer yet. That might be something we do tomorrow. Test the vector similarity. Let's see. Okay, so how would we do that? The output is going to be a token. So I only want to use the embedding. So I need to go to inference mode. So on our forward pass, we need to return after this. So if self.training I think we do that, maybe. Let's try that. Let's see if that works. Okay, good. And then we can infer. We say sample model. And then we're going to give it some sample words. We say when you spam. See that there. Actually, let's just do one word, when. Zergio, thank you for the sparkles. Hey, we got 2 sparkles from Zergio. Appreciate it. We got some sparkles over there. Sergio. Thank you so much. You're making me feel like a real streamer. Like a real live streamer, you guys. All right, let's keep going. So we got our sample output. Let's do win, and we do another. So let's do, I'll say like S1 and S2. And we say bot. And then we're going to say print S1, S2. And we'll say print. We need like a nice delimit here to say we're done training, right? The only thing is now I need to set the model to not training. How do we disable training? You just wanted it to rank popular large language model APIs. Claude, if you want a very smart model and if you have money. Gemini, if you're broke. OpenAI, if you want good models for good prices. Oh, hey, DeepSeek is good for models for very cheap. Quinn is the peak of Chinese models, is just good. It is. Quinn's the best. If I miss some really important ones, let me know. I like Gemma 4. It's a nice, good, lightweight, locally runnable, easily model. Although that's not like a for pay, it's a run local model. Are you interested in using local AI to safeguard sensitive information? Yes. Yes, indeed. In fact, we do. We do it. All right, let's see here. Let's try running this real quick. All right, what do we look at? Yeah, there we go. That's what I'm looking for. Is that right, though? Oh, wait, I didn't train it. So I need to disable. So, PyTorch model disable training. I forgot how to do that because I don't do that very often. I know you can do it, though. Model.eval. Okay. Model.eval. And then how do you re-enable it? That's to disable the gradients. To stop Torch from tracking gradients and build a computational. So there's gradients, parameters, eval, no grad. There's an inference mode. Oops. Inference mode. How do we do inference mode? Torch.inference mode. Oh, really? I just can't say. All right. There are bigger ones too, though. They need more memory. That's right, Wisdom Nuggets. They sure do. You run Gemma 4 locally and needs 6 gigs of RAM. That's actually pretty good. That's really good. For pure inference or data processing tasks, regardless of the context matter used, it'll be which one sets model.training to false. Train false. Eval. Hey, all right. Yes. Okay. So I need to do model eval. I think we can just say model.eval. Yeah, okay. So we had it right. We had it right from the get-go. I should see a big boot. Yeah, there we go. That's what I'm looking for. Look at that. We did it. We built our own. We built it. Oh, that's so cool, you guys. Look. We built our own embedding model. Not only did we train it, but we built it. We built it. That's so cool. We did it. Whoop, whoop. We did it. Don't it, dude? Look. Hey, you remember those the embeddings that you get? I don't know if you've ever used this, but there's an embedding API with the various providers, especially with like OpenAI. They've got like an embedding model that you can do. Hey, look, we did it right there. We built. Congrats. We did it. Congrats, G. Thank you. I knew I could do it. Yeah, right? Exactly. We did it. Oh, that's very satisfying. Oh, that's so satisfying. Now, oh yeah, right there. It's so good. Now all we have to do is like feed a whole bunch of data, and then we can like get it to actually work in the real world. It can work in the real world, you guys. So hype. We did it. Nice job. Thank you. We did it, you guys. All right, so the plan for tomorrow, thank you, appreciate it. That's so good, we did it. Plan for tomorrow, we will visualize and start doing cosine similarity. So we'll do cosine similarity that allows us to start doing classifications. We will be able to define some classes. That means that seems like bad words or things like happy thoughts, right? We could do happy thought classification. Then we could do like people, places, and things. We could do stuff like that. Like there's a whole bunch of different things. And then we could train on byte pair encoding maybe. We could do BPE. How would you structure the data to get the best bang for a buck in this system? Yeah, that's actually the best question, don't it, dude? Like I was saying BPE, right? Byte pair encoding, which allows us to do compression on the words. So essentially you're taking multiple words. Hey, I was going there. High potential. Hey, high potential. How's it going? I might do, so instead, high potential, I'm going to read your message here in just a sec. So I might do, so you say when you see the word like when, it might be converted to like WH and EN as two separate tokens, right? So I might do something like that. I'm not sure. Take your time, TY. Okay. There's a bunch of different options and it's usually about order, right? So we need to provide enough context to provide meaning between each of the words. So things like you found something, you found a thing, which would be the bug, a noun. And then when you spam, we'll send, there's like a whole bunch of different meanings that we can have there. And we can have different sizes now that we've got padding. So when I create this structured data iterator, we need to shuffle data. And then I also need to create various lengths of the context, like between 1 and 10, for example. So that way right now I have a fixed context of 3. And so currently fixed. So it's actually got to go the opposite direction here. Let's go arrow. Perfect. So that's what I would do, don't it, dude? All right, high potential. Let's read your message here really quick. Don't want to derail your current topic. Currently, let's say current. Curious if you have any insight into whether persistent versus non-persistent worker matters much. I'm having memory bottlenecks or leaking issues. Assuming a persistent worker only really matters for massive data sets. I'm working with 10,000 spectral samples. So these are images, right? Or like photo censored images. Curious if there's something I'm missing about the difference. My data loader batches on the first iteration, so I don't think I would have any per epoch timing saved with persistence. So you say you're running out of memory. You shouldn't be the data loader and your iterator. So I know there's a number of workers, right? What you should probably reduce the number of workers. I'm not sure. Like it depends. It's supposed to load just a little bit of data at a time, run it through your model, and then free it. So if you're running into out of memory issues, you're ooming. So like OOM. It sounds like your data loader is broken. It seems like, how big is your batch? But that it shouldn't matter because your batch should still be able to fit easily into memory, right? So if batch size is 64, batch of 64 images should easily fit into memory. So I think there's something you need to configure with your data loader. You're only using one worker. That's good. 4 in pre-training. Since the GAN with EMA generator having no memory issues. Hence why I don't think I should really care, and persistent as a default is fine. So, okay, so you can run it in multiple runs, right? You just need to save your model and then reload it every run. So say you know that you run out of memory after 1,000 or 1,000 samples. You'll loop until you hit your threshold, write your model to disk, through whatever model saving approach you're going to use, exit, and then reopen, and then reshuffle your data and start over. Reload, right? So non-persistent is okay. Yes. I think that'll work. It'll perfectly work fine. It'll absolutely work. Let's see. Oh, sorry, missed some of your messages, you guys. Let's get to your messages and we'll wrap up here. Yeah, it's a 1D spectral data, so memory is plenty. Oh, hey, cycle again, do weird stuff over batch size of 1. So unfortunately, you're locked into that. Oh, really? Well, it feels like you could do a little bit more. Sounds good. Thanks for sanity check. You're welcome. YW. Hope that gave a little bit more thought on the matter. Maybe I was your rubber duck, right? Maybe I was your rubber duck there. How would you structure the data to get the best? Okay, so I read that one where if you were to initiate a new venture today, which domain would you prioritize for performance? What do you mean, Austine Fuels. I keep calling you Austine. There, you only have one T. A .com? What domain would you prioritize for performance? What do you mean domain? Obviously domain name, right? Loons was saying a .com. What kind of domain are you describing? I'm kind of curious. What if AI could create its own words to describe what it sees often? It does. It can create its own language. It already did. At Shiv, it already has. You can look this up. It's come up with its own language. I forgot what it was called. It's something speak. It's something speak. AI audio language, not converter. AI audio language, created by AI. What is that called? Gibberlink. It's called Gibberlink. Here you go. It's called Gibberlink. I think if people keep trying to sell AI as AI will fail. You should build tools that use AI in the background and solve the problem. Kyle, exactly. You figured it out. I love Stephen Blum, the technician. Hey, Loons, thank you. That's really great. I appreciate it. Nice compliment. Have a nice evening, Mark Lemon. Good to see you. Interesting, yeah. When I say domain, I'm referring to the industry. Okay, got it. Yes. So I wouldn't do education because that is difficult to make a profit in. I would focus. So if you want the most profit, it depends on what you're optimizing for profit on. So there's a couple of approaches. One is you can go into private business for corporate enterprise. You'll get the most profit there. The second option is consumer. So a consumer good, right? Something that the consumer is going to use. An end user consumer. So you're selling to an individual and not a corporation. Those are two broad initial starting points. So then you get into like entertainment. Entertainment is a good one. That could help. That could be pretty fun. And what else? Like games and media and things like that, right? What's some other options? I'm mostly from the business side, and I think about different ways to optimize business workflows. And for me, that's where I would go. I would go on that side of things. I would say, what are the problems that you're facing? What things are you spending a lot of time on at your work today? What are you running into? What are the things that you wish you didn't have to deal with? Then I would build a product solution around that. Using AI, like Kyle described, without really selling the AI part of it and just saying, hey, this will do it for you automatically. Was an awesome stream. Donut Dude, thank you. Yep, we're wrapping up now, you guys. Thank you so much for joining. America's biggest export. Entertainment. Yep, Hollywood. You got it. You love the iCaggy approach? What is that? I need to Google that. What is that? Whoop. We don't want that. We want this. What is this? What is the iCaggy approach? A quick look at that real quick. Oh! Concept of meaning, a reason for being. Love, pay, good, need. Vacation, profession, passion, mission. And then the Vandelbrot. Japan design philosophy. Ooh, that's a good one. You're amazing, Zergio. You're amazing. Thank you for saying that. Appreciate it. The Ikigai. Oh, the Ikigai. Ikigai. Yep. Ikigai. Right? Ikigai. I see it right there. Spell it out right there. Thank you, Donut Dude. It's good business. All right, you guys, we're wrapping up for today. I had a lot of fun. Thank you so much for joining. We'll be back tomorrow. Ha ha. We can't wait for the stream tomorrow. Bye, guys. Had a lot of fun. Thank you, everyone, for joining in. We'll see you guys tomorrow. Much love, broski. Thank you, Donut Dude. See you guys. She is Shiv. See you, Loons. See you, Kyle. Donut Dude. Zergio. Zergio, thank you. Austin. And Mark Lemon, if you're still here. Good to see you guys. We'll be back tomorrow. All right, the plan for tomorrow, we're going to continue with our embedding model, and we'll make it work. We actually already did a really good job on it. We're going to make it actually be useful at that point. All right, you guys, had a lot of fun. See you tomorrow. Bye, everybody.